Hello, my name is David Todd, and I'd like to expand on my previous video about microservices, but talk about Linux robots in UiPath and how much it really changes the game and enables things for administration as well as making the microservices work really fast. I've got a framework here I'm going to talk about, Introduction to Linux Robots. Linux robots, you don't have any custom computer VM, there's no maintenance, there's no SOE, MOE. You just get an image from UiPath and that's it. It's a Linux robot, it's got stuff installed on it, and when they give you a new version, that's when you get the new version. So there's no provisioning effort, trivial provisioning effort. Right now, as the time of writing, the latest robot image version is 22.10.3, but I am told a new one's coming out very soon. You don't have a live, always-on computer. So if you have a Windows box sitting in the corner, it's live, it's turned on, it's chewing up power, even when it's not doing anything. All these Linux boxes start up, do what they got to do, shut down again. They're really clever and they scale really well. There is no custom software on them. You don't install Office, you don't install your little Windows app. You get what you're given with no custom software. So what we're looking at here is cross-platform compatible processes, automations. So you've got a limited subset of activities that are cross-platform compatible, but all the basics are there. Everything you really need is there. You can only automate the Chrome browser, use APIs and connect to databases. That's it. There's no doing anything else. Interactive activities only support the Simulate and Chromium API input methods. If you don't know what that means, don't worry about it. Targets are only generated using the strict selectors and the fuzzy selectors. Again, if you don't know what that is, don't worry about it. It's all automated in Studio. It works. The RE framework is not currently supported. This doesn't bother me because I feel the RE framework's anti-scaling anyway. It actually is an inhibitor to scaling well. So if we're talking about Linux robots, you've got two types. You've got really two ones I'm interested in anyway. Serverless and Docker. Serverless robots live on the UiPath cloud. They're managed by the UiPath cloud. You never see them. Here's a demonstration for how to make a serverless robot. You go to your tenant, you go to machines, you go add machine, and you go cloud robot serverless. Give it a name, give it a description, give it a tag, and hit provision, and that's it. It is done, finished, ready to use. Nothing more to configure. I'd like to observe here, you talk about the runtime units and the size. A small one has 1 runtime unit a minute, standard has 2 runtime units a minute, medium has 4, and large has 10. You get the idea. But that's how easy it is to provision a robot. Robot bundles I want to talk about quickly. All the serverless robots use robot bundles, X many depending on size per minute of actual runtime. They're bought at 7,200 bundles in 7,200 units in one bundle per year, which is 6,000 a month, and at the end of each month they expire. This is unfortunate because I can see a scenario when you might use a few units, and then you get to end of year processing and you want hundreds of units. You don't want an equal sustained amount per month. You want to spike when needed. I'd like to see that improvement, but it's still really cool and really good, and the demo will show you this. The other option is Docker. So on a demonstration, provisioning Docker, this is really simple. Again, tenant machine, add machine, standard machine template. Give it a name, give it a description. You want to say that it only does background processes. You want to say that it's cross-platform only. And you want to give it the licenses. How many licenses we got? 1, 2, 3, 5. However many robot licenses you want, or testing licenses. And again, you hit provision, and off she goes. That's the first half done. When you do that, you'll find that you get machine templates. That machine template has a machine key. This is really important for the second part. The second part is provisioning in Docker. So you have Docker. This is Docker for Windows. You can get Docker for Apple Macs. You can get Dockers for Linux. Docker works just about everywhere. It runs on the cloud, AWS, Azure, etc., etc. And once you've installed that, you have to give the command to install the particular image from UiPath. That's the image here. Docker run. Obviously, run something in Docker. E means here's a piece of information. Accept the license agreement. Here's the orchestrator URL, clouduipath.com, organization name, tenant name, orchestrator. Machine key is the machine key you get from your template, and then this thing here, that is actually the path to getting the image from UiPath. As you can see, it's robot 22.10.3. When they release a 23.4, just change that to 23.4 and you'll have it. When you tell your system administrators you need a new version, just tell them to run that, it upgrades, done. It is that simple, you have it deployed. It is really, really, really easy. So, everything I wish was that easy. As you can see now, this Docker I've got here is your standard one, UiPath 22.10, and it's currently running. There's a stop button, and if I stopped it, there's a play button. It's that simple. So, that's everything I wanted to talk about briefly about robots in Linux, microservices demo. First thing I think is important for microservices is you've got to set it up so that your job strategy really works well and is picky. Otherwise you find that you get extra processes you didn't want running that run magically. So go to tenant settings, execution settings, triggers, queue triggers, enable pending jobs, and set it to false. It defaults to true. That'll make all your problems go away when you start seeing processes running for no reason you didn't expect to. So, logical flow. Here's what we're going to automate. We have an app, UiPath app, with a field you can type in a name, Dave. That'll fire up stage 1 process, which basically logs, hey, I've got the name Dave. Picks a random number between 1 and 3, starts 2A, 2B or 2C, depending on the random number. 2A logs new and improved, Dave. 2B goes transmogrified, Dave. And 2C goes Shazam, Dave. And then whichever one it is, they all start stage 3, which says finished, name Dave. So it's pretty straightforward. There's nothing particularly strange or difficult there. But it's the example we're going to run through. So if I go to the orchestrator, what we have in my folder is automations, processes. There's your stage 1 process, 2A, 2B, 2C, stage 3. We're making these communicate, we're making these start each other off with queues, much like the RE framework does. So I've got a stage 1 queue, 2A, B, C queue, stage 3 queue. Nothing surprising there, they're all triggered up to run this right process. So just to prove it, if we go to triggers, queue triggers, stage 1 trigger, start stage 1 on stage 1 queue. 2A, 2B, 2C, stage 3 trigger, start stage 3 on the stage 3 queue. Pretty straightforward. The only interesting thing I wanted to show you here on the triggers is right now it's set to run on serverless cloud, job priority low. So you can see here that the robot I've set is the basic robot, the machine will be serverless microservices robot. That's the one I set up previously. The cool thing, I've actually set it a maximum of 50 jobs simultaneously. So if I throw 50 jobs, 50 queue items in the queue, it'll start 50 processes concurrently. And that's one of the things I wanted to show you. That's the same of all of them. So if I show you this is the app I was telling you about. I'm going to type in Dave and hit start. What we'll see over here under jobs is stage 1 has started, it's pending, it's queued. Not very exciting watching jobs run, I must admit. It's running. It's successful. It started stage 2B. Randomly, A, B or C, it chose 2B. 2B's running. Again, like watching grass grow. 2B's finished, stage 3. Pending, running. Not super exciting yet, bear with me. I go to the view logs. We can say here that Dave is the string it was passed and random number 2, which means why it did B. I look at the logs for 2B and we see here that it's transmogrified Dave, whatever that means, hooray. And then stage 3, that says finished Dave. So everything's working as expected. Great, you say, so what? I hit Dave 1, I start it. I hit Dave 2, I start it. I hit Dave 3, I start it. You see where we're going here. Hit Dave 4 and I start it. We can see now we've got 3 stage 1s running and a 4th pending. Stage 1's successfully finished, we've got 3 more running. 2 have succeeded, we've got stage 2A and a stage 2B. And now a stage 2C. Had some luck with a random number generator. and then another 2A. Stage 3, we're going to get 4 of those as well, all running concurrently, all scaling nicely. You can have 50 stage 2s running, and 50 stage 3s running, and 50 stage 1s running, all at the same time, scaling, with no mucking around with configuration or anything. Okay, it's all run, it's all successful, hooray. 4 stage 1s, 4 stage 2 whatevers, 4 stage 3s. Now, I'm going to do exactly the same thing, but I'm going to do it with the container, the Docker container that I showed you earlier. How easy is that to change? Triggers, queue triggers. I'm just going to change stage 1 and stage 3. So we go from serverless to unattended. Basic robot, any machine will work, but I can say I want my Docker Linux template machine. Just like that. Now, because I've only got one license, you're only going to get one job running concurrently. Even that's set at 50, because I've only got one license configured. So I've done stage 1, I'll do stage 3 as well. Great, now let's run another one. Let's just do day 5. Start it, and go back to our jobs. Stage 1, different host name, that's running on Docker. Stage 2B, running on cloud just like before, nothing's changed. Bit of trouble updating that. Stage 3, back to Docker again. So you can have some on Docker, some on serverless, some on Windows as well. You can mix and match to your heart's content. If I was to look at the stage 2B logs, it'll have day 5 there. Transmogrified day 5, so hooray. So that's a very quick demo of serverless and Docker. What if you need a Windows robot? I'm not a fan of Windows robots because you're going to have a MOE, you've got to install things, you've got to maintain it, it's running all the time, it's got to run on premise, someone's got to look after it, update it, someone's got to make sure it's working, reboot it. They're just painful, but if you have to have one, have one. In my mind, with microservices, every application you automate is its own automation. So when we source data from here, that's an automation. When we write data here, that's a different automation. When we send an email, that's a different automation. Business rules get their own automation as well. Maybe writing to a database gets its own automation. Maybe building a report gets its own automation. The bit that needs to run on Windows with your special little Windows application gets a Windows robot. Everything else, your business rules, etc., still runs on Linux. Clean, easy, simple, fast. Thank you very much. I'm done for the day. Have a great day.